Okay, when we were talking about the single player mode, we had the single player button that had to be pressed. And if we look at the code for the single player button, as you can see, it's rather simple. It just starts up the game and doesn't do very much. Now, if we look at the team player button, you'll see that in the team player button, um, it's more significant. And what happens is that we have to first connect to the server. So that's what this method does, this multiplayer method connects you to the server. And as soon as you're connected to the server, this event will occur on connected to master. And you'll notice that we're giving the command to join random room. Now, if the room doesn't exist, we're going to get a on photon random join failed. And in that event, we want to create the room. And it's an anonymous room with maximum of 4 players. All right, then as soon as the room is created, we immediately will join the room, and when we join the room, we get on joined room, and the first thing we do is we come in and we check to see how many players are in the room. If at this point there's only 1 player in the room because I created it, so we'll come down here, you'll see where the message waiting for players is displayed. These flags are used to handle the cancel button. A GUID is created to identify the client. In this case, it isn't really necessary because there are only 2 players. But if you have a game that has multiple players, 5, 6, 7, 10, 20, you want to be able to distinguish between each individual player. You want to know that this is player 6 you're talking to. You want to know if it's player 12, and so forth. But at the same time, you still want to address them all as players. So the way you do that is you create a unique ID, and then you assign that unique ID to the particular client. And because this is the first player that created the room, they're defined as player number 1. I'm using the player preferences to store this information because it's the only way to have persistence between loading of scenes. You'll also notice that I have the tag called master, and I set that value equal to 1. That's because this was the first one that created the room, and so it's also the client and it's also the master. I mean, it's the slave and the master. And so I indicate that with the 1. All right. Now, so there I am waiting for other players to join the game. So go back here. The other player joins the game. Another player presses the team player button, and it'll try to connect to the server. Now the person's in the lobby, and the command and this event on connect to master will be fired, and it says join random room. And now there is a random room because there is a room to join because I created it. So they'll go directly to the on joined room. We'll come in and check to see how many players in the room. At this point, there are 2 players in the room. As you can see, we're checking for 2. So since there are 2 players in the room, we're ready to play the game. And I assign a unique GUID for the other player. The master is set to 0. The master tag is set to 0 because it's the slave. And the player ID is defined as player 2. And then we begin the game. Right? So if we'll go to the begin the game function, and you'll see what it does is that it essentially does the same thing as it does in the single player game. The only difference is when we go to the when we go and look at the home controller screen, and you'll see this is where on the home controller screen you see asteroids being generated, and it's just, you know, showing you the home screen, you'll see that when the game over is set to true, it'll fall through, and now it loads the level of the Photon network. It loads the Photon level. And again, I'm using the player preferences, and I've defined main screen as 0, and as 1, and I define home screen as 0. So I'm telling it to load the main screen. All right, then exit the loop, and the thread goes away, and now I'm in a wait state for the main game screen to load. So the main game screen uses the game controller script to facilitate what's going on in the game. And so when the script comes up, you have your normal initialization, and then there's update. Now, what update is doing is that update is waiting to see, it's using a remote procedure call, and it's asking, has other scenes been loaded? And it'll continue to ask that question, because you'll get it if the scene hasn't been loaded yet, and you try to execute that remote procedure call, you're going to get an error back that says remote procedure call doesn't exist because the scene hasn't completely loaded, the scripts haven't been completely instantiated, so there are no objects, and you have to put this in a loop. And you'll see this update flag that I'm using that is being checked to see whether, at some point, do I stop doing this? So we'll go to the send remote scene has loaded method, and you'll see it's just a wrapper method that calls the remote procedure call, RPC, remote scene has loaded. And you'll see that in the remote scene has loaded that I'm checking to see, is it mine? That's what this photon view is mine. And I'm checking to see what scene it is. So I want to make sure that the right scene, it was the right scene that was loaded, so I'm not still looking at scene 0. I'm actually looking at scene 1. And I need to know that this is not me. So because when you make a remote procedure call, the server will send all the clients the request to execute that remote procedure, including yourself. So you don't want it to execute twice in your game, and that's why I'm checking this photon view property that says is mine. And in this case, I don't want it to be mine because I'm the one that initiated the call. And it increments this scene variable, and then it sends me back an acknowledgement that says it did do what it was supposed to do. The screen did load, it did execute the remote procedure, and it sends me an acknowledgement. So if we look at the acknowledgement, what the acknowledgement does coming back is it sets that update flag to false, and now I'll stop asking to see if the screen is loaded. And now, one side is loaded. So we talked about the master client gets events that the slaves do not get. So, for instance, one of the events is one of the events is on level was loaded. This event will occur only in the master client. It will not occur in the slave clients. So when the screen loads, what happens is that it will set the sync property, it'll increment the sync property to show that it's loaded. And it'll stop asking the other ones, have the other ones loaded yet. All right. Now, because the clients don't get this event, I have to do that in this function here called spawn waves. Spawn waves, when the scene completely loads and is running, it's going to execute this method called spawn waves. And you'll notice in spawn waves, I'm incrementing the main scene, and then I'm putting out this message saying transporting. So now, since the other player has already joined, the other scene has loaded, it would be 1, and then I do it, it's 2, and now we've both scenes are loaded, and it'll fall through, it'll go into this wait state, and here's where I'm waiting 10 seconds. This is a judgment call. You can wait 15 seconds before you drop the players in, 20 seconds, 30 seconds. It's up to you on how you want to handle it. If you make it too long, the player gets bored. If you make it too fast, you'll get synchronization issues. And here you'll see it creates the player object. And if you look at the player object, you'll see that it checks to see, is it a master client? If it is a master client, it'll instantiate the photo network player as player 1. And if it's the slave, it'll instantiate the photon network player as player number 2. Also notice this other one called create player. This is for single player mode. It uses the Unity instantiate, and it uses this member variable. The network one uses a completely different member variable. And it just seemed to me to make it easier this way, because I didn't want to deal with putting some sort of dependency between the single player mode and the multiplayer mode, and then find out I make one change and I have a bug somewhere. Okay, so once everything is dropped into the scene, then it goes into the loop where it creates the hazards. And you have the gameplay. So the next thing is, let's talk about the hazards. In a single player mode, these asteroids are generated randomly at random positions, at random rotation rate, and so forth. Now, we need them to be the same on all the clients. So the easiest way to do that is to use the photon network instantiate command, because what that'll do is that'll create the asteroid on all the clients with just this one call. So I don't have to worry about rendering on all the clients. Now the problem is I need this to happen only once. I can't have all the clients creating asteroids. So that's why I'm checking to see, is it the master client that is executing this script? If it is, then I'll create the asteroids. If it's not, I'll ignore the creation of the asteroids. Okay? And that's how we handle the creation of the asteroids. Another issue was the firing of the laser. Let's go to the player script, because that's where the firing of the laser is. And we'll go to the we want to get to the fire laser bolt method. Here we go, fire laser bolt method. All right, so the issue that we had with the laser bolts was in the single player mode, I would just, when the button was pressed, I would fire the laser. So if you hold the button down, the laser would fire repeatedly and you'd have a stream of laser bolts coming out. When I used that same principle with multiplayer, what happened was that I would use a remote procedure call to tell the other clients that a laser bolt has been fired so that they should generate a laser bolt. When you hold the button down and you get the stream on the originator of the laser, when you press the button, on your machine, you would get the stream of laser bolts. If you look at the other clients, you may get 5 laser bolts, maybe 3 laser bolts, maybe 2, and they're spread out, which is telling me that the remote procedure calls were dropped. So clearly I can't do it this way. So what I need to do is I need to have it act the same on all the clients. So I use the concept of a shutter. So this is a while loop, and what it does is that it checks to see if a flag is set to 1 or 0. And if that flag is set to 1 or 0, it'll essentially opens the shutter and just a stream of laser bolts will be instantiated. This way, all I have to do is pass one remote procedure call that says open the shutter and one that says close the shutter. And now the laser will fire repeatedly on all the clients the same way. That's how I got around this issue. Now there was an idiosyncrasy with the Unity engine on how it handles mouse clicks. And so the engine looks at a mouse click as the fire button's been pressed. So on the screen, we'll look at the main screen here. Let's go to the main screen where you'll see the buttons down here. What would happen is that when I would press this button to move left or move right, the engine sees that I had a mouse click on the screen. So the engine, the mouse click means the fire button has been pressed, because that's when you have a joystick and there's a button A, that's the fire button. It starts firing the laser. So as I'm moving, the laser is firing, which is not something that you desire. Okay. So what I had to do is that I had to use I had to modify the shutter concept. So I had two shutters. There was a front shutter, the first shutter, and a second shutter. Now, the second shutter I would close the second shutter when I press the button to move, and I'd open the shutter when I press the button, when I release the button. Now, the first shutter is always closed. So this is how it prevents the laser from firing. So you don't see it firing. But if I press the laser button, it will automatically open both shutters, regardless what the state is, and the laser will fire. This is so you can hold the button down on the left and move to the left, and while you're moving to the left, you're pressing the fire button at the same time, and you get the rapid fire of the laser. Okay? So let's go into the move now. When I did the move, I had the same problem. I would send the remote procedure call that I had moved, and it would miss the procedure calls, would get dropped. So the ship would move at one rate on one screen, and then at the other screen it would move at a different rate, and they weren't synchronized. They'd be in different positions, and that was undesirable. So I used the same concept as the shutter. A position is generated and it's in a loop, and what will happen is that loop will the loop is created by this input, input here. Okay, so the loop is created with this. So what would happen is that you press the button. It essentially is equivalent to opening the shutter or releasing a clamp, if you want to call it a clamp, and the ship now starts to move, and it moves at a certain rate. And when I release the button, the clamp gets put down again, and then the ship doesn't move anymore. Now, when dealing with the laser, all I had to do was 0 and 1, because the laser was on, the laser was off. When you're dealing with the moving of the ship, you have to deal with direction as well. It's not just I need to move. So the way I handle this was, if we look at the up button, and you'll see that there's a move. So this move ship vertical, you'll see that when I press the button down, it sets it to 1, which is going up. And when I take my finger off the button, it sends a 0, which essentially says stop moving. Okay, the clamp goes down and it stops moving. And this will move, because this is a 1, positive 1, it'll move in the forward direction. If I go to the down button, you'll see that it sends a -1. So not only does it release the clamp, but it also gives me a direction, so I know in which direction to go, so I get 2 pieces of information at the same time. And this is the code here that handles the idiosyncrasy with the laser. All right, which I'm closing the second shutter and so forth. If we look at the to the right, okay, it's a +1. If we go to the left, it's a -1. So we have that. Now the other issue was the tracking of the score. So in order to track the score, I tried to do the RPCs, and that was also another problematic. And it kept on missing dropped procedure calls, and the score wouldn't be updated properly. One player would have a different score than the other players, and that was unacceptable. So I used this on-photo serialized view. Now, this photon serialized view is a special event that executes in a particular manner. If you're the master client, you will get both the ability to write to the stream that sends information to all the other clients, and you'll get a receive stream, which is where the information comes to you from the master that's sending this. Now, if you have the master, if you're the master, you'll be able to send. If you're the slaves, all you can do is receive. Right? So in this particular case, I used this procedure call, not the procedure, but this method here, so that every frame, what it's doing is that it's sending the score to all the players. And I would update the score accordingly. So now you'll see on the screen that the score is the same from player to player to player. But every once in a while, if you look closely, you'll see it might lag a bit. And that has to do with synchronization issues, again, network issues, speed, and so forth. You know, the speed of the machine, and it'll lag for a moment. But on the next frame, the score will be updated and everybody will see the same score. Okay? So that pretty much handles the issues that I had to deal with in the multiplayer game. Well, thank you for your time. And we'll say goodbye.